Hey guys, this is Mr. Lotus. Some of you said, "Who is that?" That's not you. Yes, it is. This is me, Mr. Lotus. So we left off talking about bubbles and phospholipids. So let's talk about diffusion. So first of all, passive transport versus active transport. Really easy. Passive transport is transport that does not require energy. Active transport requires energy. Diffusion is something that happens in physics. It's just a natural tendency of physical matter. So basically, particles want to spread out evenly in space. Okay, if you leave particles alone, what they do is they tend to spread out in the universe. And this is called diffusion. Think about if you spray some perfume in one corner of a room and think about how it spreads around the whole room. It doesn't just stay in that one place. Particles like to spread out until they are evenly distributed across space. So this is not requiring any sort of added energy. This is just something that happens with particles in space. Okay, they like to spread out. So if it does not require any energy, it's called passive transport. So the first type of passive transport we're going to learn about is diffusion. So let's just look here. These particles want to spread out because things always want to spread out and they're always moving. Okay, small particles are always moving, atoms are always moving, they're always vibrating. And if we look at something like a membrane here, okay, this membrane is permeable to these particles, which means the particles can fit through the membrane. So over time, the particles will spread out until they are going over onto both sides of the membrane. And now here's where some students get confused. They think that, well, once it's all spread out, then everything just stops. No, because particles are always moving. So even after everything is spread out evenly, particles will still move back and forth and back and forth. So even at equilibrium, where we have equal solute concentrations on both sides of a membrane, we'll still see some movement across the membrane, okay? But when there's more movement towards one side, like in this picture here and this picture here, we say that the net diffusion, okay, the net diffusion would be to the right. It doesn't mean that there's no particles moving to the left. There can still be some particles moving to the left. But overall, more particles are moving to the right. So the net diffusion is to the right until it's at equilibrium. And once it's at equilibrium, there is still movement, but there is no more net movement, okay? So let's look at two different types of particles, the orange ones and the purple ones. Well, the orange ones are highly concentrated on the left, and the purple ones are highly concentrated on the right. So for the orange particles, there's a net diffusion towards the right until they are evenly distributed. For the purple ones, there's a net diffusion to the left until they are evenly distributed. Now, it doesn't mean that movement is going to stop. They will still continue to move. However, there will be no more net diffusion once we reach equilibrium. When water diffuses across the membrane, that's called osmosis. It's just a special name for the diffusion of water. So water can go through the membrane without using any type of transport proteins. It can technically go through the phospholipids in small amounts, but most of the time, water goes through the membrane using these little facilitated transport proteins, which are called aquaporins. Okay, water mostly moves through the membrane through aquaporins. So water also does some other weird stuff, but I'll go into that in the next video.